in this unit, that is unit 16, we are going to study the mechanical technique, mechanism of ion exchange chromatography. So previously we have studied about what is chromatography and classification of chromatography and different types of chromatography and their principles, instrumentation and application. These are the main concept you should be knowing in all the instrumentation, like gas chromatography, liquid chromatography, high performance liquid chromatography. In this, see what we have discussed in the previous class, should be knowing the what is the working procedure, means the principle of that instrumentation and their working procedure and the application. These are the three main criteria you should be knowing, whatever the instrumentation they give. And other things like which are the detectors we will be using. These are all be not that much important compared to the should be basic thing is they should be knowing the principle of the instrumentation, which one you are going to write. So in this today I will be explaining about ion exchange chromatography. That is the last unit. So it is a solid liquid chromatography in which stationary phase is in solid and mobile phase is in the liquid. So this known as solid liquid chromatography. So in this, what is the principle of this ion exchange chromatography? Here we are going to study the molecule separation on the basis of their charge or eluted using solution by using different solution of varying ionic strength. So here we are going to separate on the basis of the charge. So ions will get exchanged between the mobile phase and stationary phase. This is the basic concept in ion exchange chromatography. And objectives of this unit is to study the ion exchange chromatography and their principal techniques and type of ion exchange, anion exchange and cation exchange will be taking place in this, and effects of complex ions, zeolite as an ion exchanger and their application. You are going to study the applications of ion exchange chromatography. And as I told in introduction, see, ion exchange chromatography is a solid liquid chromatography in which the stationary phase is in ion exchanger resin, means stationary phase is nothing but the solid. So and mobile phase is in the liquid. We may use water or some other solvents for the mobile phase. So the basic concept is we are going to find the ionic active groups such as hydrophilic can exchange reversibly and while using it as a mobile phase and having some charge present in the solution. So here exchange may be of cationic or anionic. There will be two types of reaction taking place in this ion exchange chromatography, that is cation exchanger and anion exchanger. In cation, X is an sample in both. X is denoted by a sample and Y is the mobile phase what we are going to use, whether it is an anionic or cationic, for example. And R is the ionic site of the exchanger. How much the Elute. What we have got the elute? How much percentage of the sample is exchange between anion and cation? So here in the example, we have taken styrene. Yeah, this is known as styrene, and with the divinyl benzene. Here polyester polymer cross-linked polymer has been formed while using divinyl benzene. So styrene, why? What is the use of styrene? Styrene it may use for the synthetic rubber and polystyrene resins. It can be used for the polyester resins and polystyrene. What we have got the product here? Polystyrene is a synthetic polymer made from monomers of the aromatic hydrocarbon structures. These are the aromatic hydrocarbon structures where it is made up of monomers such as styrene and divinyl benzene. So here the cation exchanges the resin used called cation exchanger. So here cation is getting exchanged between the mobile phase and stationary phase. So where an ion changes resins and called as anion exchanger resin here. This is the example. If you get into the topic, you will be knowing here. This is the cation exchange. In this topic, we are going to study cation exchange resin. In cation exchange resin, it is having dimolecular cross-linked polymer, which is having sulfonic, carboxylic, and phenyl group in the internal part of the resins. So this sulfonic group carboxylic is nothing but the RSO3. This is denoted by RSO3. So here mobile phase is, if you take an example, I will show you in the example, you will be knowing easily. This is the column. So here in the mobile phase, we are adding cations, which is denoted by B plus, and in the stationary phase, we are, that is resin, which is having anions, that is A minus, can be denoted by A minus. So here resin is the basic polymer. So when it is basic, the polymer is attached to the anion and the mobile cation B plus is shown here. This is the mobile phase when it comes to the contact with the stationary phase, which is resin. The ions get exchanged. So the strong acid, for example, the strong acid cation exchanges resin, which is having sulfonic group. As I told here, sulfonic carboxyl, it is RSO3H. RSO3H group, sulfonic group attached by polymer matrix. Where in the weak acid cation exchanger, resins having carbolic acid. This is nothing but what you are studying in the acid base, or how the weak acid reacts with the base, or a strong base, or a strong acid reacts with the strong base or a weak base. That itself same procedure you are going to follow in the ion exchange chromatography. Here in the weak acid cation exchange resin, the carbolic acid group attached to the polymer matrix. This in cation exchange can be represented here as R. as I told earlier, it can be represented by R. So the strong acid cation exchange resins are usually supplied by sodium form, which can be denoted as some of the sodium form. It can be hydrochloric acid or converted into hydrogen form. So by using strong acid versus weak base, or weak base versus strong base versus weak acid. So this is in the cation, the positive charge will be exchanged with the resins which is in the mobile phase, and it is separated. So next is anion exchange resin. Here negative charge ion. This anion is nothing but the negative charge ion, where it is anion exchange resin here, where in the mobile phase we are going to use anions for separation. Anions, which is denoted by A minus, and in the stationary phase, which is cations, will be there. So this is the difference between the anion and cation exchange. Cation, uh, which is denoted by B plus. So this is the basic concept between the uh, cation exchange resin and anion exchange resin. Here, the strong base anion exchange resin contains, which is having minus, yes, see, the strong base type of anion exchange resins, where minus n plus R is denoted as what? In the previous water, it is denoted as the resin, and group where weak base exchanges the anion exchange resin contains. This is the exchange reaction taking place in this. So anions are coming in contact with the resin, which is having the cation B plus, and separated and getting exchanged. Yeah, so this is the basic concept ion exchange chromatography, where the title itself says ion exchange uh, using the chromatographic technique. So this is the basic concept, anion and cation getting exchanged in the chromatography. So here mechanism of action. Before here one more is there. What for the strong for different separation we are going to use different stationary phase. For example, strong acid cation exchanger resins, which will be using zeolite, amber light, and Dovex. And for weak acid cation exchanger, we are using zeolite 226 amberlite, and strong base and ion exchanger uh, resins, which is having zeolite FF. And these are the some of the, to know what are the station phase we are going to use. They are given some of the example for strong acid cation exchanger resin, weak acid cation exchanger resin, and the strong base and ion exchanger resins, and the weak base and ion exchanger resin. And further, in the mechanism of ion exchange chromatography, this you should be knowing how the mechanism taking place inside the chromatography. So diffusion of the, when the mobile phase is introduced into the stationary phase, the diffusion of the ion taking place in the exchange of the surface. The diffusion of the ions takes place in the stationary phase of the surface. So that is the first point they have explained. And the diffusion of ion through matrix structure of the exchanger to the exchange site means the diffusion of the mobile phase in the stationary phase takes place, and the matter structure of the exchanger of this exchange site is taking place in the second step. And in the third step, exchange of ions at the exchange site instantly means exchange of ions. What I have told, exchange of ions taking place, whether it is a cation exchange regime or anion exchange regime, the exchange of ions will be taking place in the while it gets mobile phase comes in the contact with the stationary phase, and further diffusion of exchange ions through exchanger, and it is separated by elute. So the selective desorption by the elute or diffusion of the species into the external solution means the selective desorption which is taken place in the mobile in the stationary phase, it is eluted and the ions get exchanged. So this is the mechanism of ion exchange chromatography. How the introduction of the mobile phase into the stationary phase, and how the diffusion taking place and the exchange of ions takes place, and further diffused the exchange ions are eluted. So these are the what explained in the 5 steps. And next is, what are the factors affecting the ion exchange chromatography? Means some of the criteria will be there. It may affect. It should be within their limits. So, what are the some of the factors which are affecting in ion exchange equilibrium? So, exchanging should be in the equilibrium, exchange of cations and anions. So, how this will be in the equilibrium factors affecting the ion exchange chromatic ion exchange equilibria. So the factor determining the distribution of ions between the ion exchange regions and solution includes the following factors here. Nature of the exchange ions. It mainly depends on the exchanging of what? Exchanging of the chemical compounds, ions, what we are going to take. So nature of those chemicals should be important here. So the ion charge plays an important role to determine the capacity to undergo exchange reaction. So here ionic charge plays an important role. That's all. In the ion exchange chromatography is the importance of ion only. It plays an important role to determine the capacity to undergo the exchange reaction. So here we are taking cyanide by decreasing in the following order. This is the exchange of H plus ions taking among the cations in the decreasing order, which is in the decreasing order. So this is the example what you are taken. That's all. This is not the for all the experiments you are not going to use the same criteria. So this for the example here, cyanamide is greater decreases while further alumina which is in Al3 plus and calcium Ca2 plus and Na plus. This mainly depends on the H plus ions present in the given chemical sample. So this is the ionization taking place. So this indicates the regions preferring the ions of the highest charge in a series of ions. So it depends on the ion charges present in the chemical species. So next is the capacity among the anions. This is the capacity among the anions of the same size has been found to decrease in the following order. If it is having the same size, means it is having the same, for example, phosphide, sulfur dioxide or iodine, which is decreasing in the order which is shown here, uh, which is having the same size. It can be denoted here PO 3 minus SO2 minus. This is not S, this is the 3 minus PO 3 minus, and SO2 minus decreases with iodine. The phosphate decreases with sulfur dioxide, and further it is decreased by iodine. So this is the decrease in the where OH minus ions in the anions have been found decreasing in the following order. So if we compare, next is the ions carrying the same charges in the size of the hydrate ions plays an important role to determine the capacity to undergo exchange reaction, which is having the same charge. Some of the ions which is having the same charge and the same size, it depends on the hydrate of ions. While using uh, mobile phase such as water, mainly in ion exchange chromatography we will be using water as the solvent. So here hydrating take place, and ion plays an important role to determine the capacity to undergo exchanges. So this here the cation exchange results for H plus ions. Here it is in the decreasing state where cesium decreases for rubidium and potassium, further sodium and lithium. Here size has been found decreased. Uh, it mainly depends on the size. So if it is having the same charge and the same size, the order is given in the decreasing order of the size. So the ions with the smaller hydrated radius is more strongly held by the resins. Resin is used as a stationary phase in the ion exchange chromatography. So here, which is having small hydrated radius, the ions which is having, for example, in this cesium, rubidium, potassium, and sodium and lithium, which is having uh, small hydrated radius, means the size of beam which is having very less, is having more strongly held together with the stationary phase, which will be having more strong with the stationary force. So the elution will be very slow. Mean the elution will take place very slow in the small hydrated radius ions. So, and the next factor is uh, which is having same charges. Uh, for example, Ba2 plus, Pb2 plus, cerium 2 plus, calcium 2 plus, CO2 plus, nickel 2 plus, which is having the same charges. Here capacity has been found to decrease the following order. It is shown in the decreasing of the following order. So in this order, the ion exchange take place. First will be in the barium and lead, cerium, calcium, cobalt, nickel, and further copper, zinc, magnesium, and manganese, barium, and cadmium. In this series, the ion exchange take place depending on the size and the charges present in the cation. So next is the among the So yeah, next topic is in this iodine, bromium, CNL, and hydroxide and fluorine, where these are the univalent anions. The capacity has been found to decrease in the following order. They are given some of the examples with the decreasing order. Should be main thing you should be knowing in these factors affecting in ion exchange chromatography depends on the plays an important role in determining the capacity of the undergone exchanges, which is having same H plus ions among cations and be found to be decreasing. So it mainly depends on the size and the charges present, which is having the same charges means how the decreasing order take place in the ions as studied in the factors affecting. So next is the experimental setup where this I already explained here solution we will be using water as a solution in the ion exchange chromatography and the stationary phase is the resin and column solution which is eluted and getting separate this is the elute which is getting exchanged and separated. So in ion exchange chromatography, the basic principle is the ions get exchanged whether it is a cation or anion with the resin. So it mainly depends on the sample which one you are going to use for the separation of the ions. So this is the experimental setup and for the and the resumes here is used to have small particle size and provides a large surface area for the contact between the solution and the resins. So resins are nothing but the polymers which are going to use for the resins are nothing but polymer or polymer precursor methods materials which are mainly used for the exchange of ions. So this is the experimental setup and further in the packing column the resins may be and some of the criteria which has to be followed. The continuous flow of the mobile phase should be there and if you stop or if it is less than the resin means the resins get dried, so you should not make the resins or stationary phase dry. uh, the flow of solution or solvent should be continuous so that we can keep the stationary phase in the wet and it should not if it becomes dry means what it will be the breakage will be seen in the resins. So if the break happens means there will be no proper ion exchange will be taking place. So directly some of the elutes may elute directly. It it won't be having any contact with the stationary phase. So the stationary phase should be well bonded and it should not be dry. So this is the main criteria while using stationary phase in the packing columns. So further, in the application of ion exchange chromatography, yeah, it is mainly used for the separation of ions from one another because the different ions undergo here in the different ions undergo exchange reaction to different extents. So it is mainly used separation of similar ions from one another. It is mainly used for the separation of ions, similar ions for one another. And for example, here taking lithium and sodium and potash ions can be separated by passing the solution using HCl. You're using HCl. But this mainly concept is acid base. So you're taking HCl used as an elute. So in the second, in the ion exchange chromatography, it has been used to separate mixtures of chlorine for lithium, sodium, and potash, which are used for the separation. These are the examples for the separation of cation exchanger. And this is the and chlorine, bromine, and iodine are used in the anion exchanger resins. Here are two types of techniques used in the ion exchange chromatography. One is cation exchanger resin, and one more is anion exchange resins. So here two types of separation can be done. So one is lithium, sodium, and potash, and one more is chlorine, bromine, and iodine. These mixtures are eluted by using sodium nitrate, and chlorine ions will be first eluted. So for different exchanger for anion and cation exchanger, we are going to use different mobile phasers. So this is the application for separation of similar ions from one another. So second application is removal of interfacing radicals. Yeah, which are interfacing radicals present, estimation of calcium and rhodium in the ions by oxalate sulfate method. So removal of interfacing radicals can be separated using this application by using this ion exchange chromatography. And next is softening or uh, hard water. The application can be used in the softening of hard water. Here, the hardness of water is due to the presence of calcium and magnesium and other divalent ions. So it can be softened by removing the ions present in the water. So means not in the water, the presence of calcium and magnesium present in the water. So this is the softening of hard water. And next is the complex demineralization of water. So whatever the minerals present in the water can be completely removed, such as chlorine, nitrogen, sulfate, magnesium, calcium can be exchanged by H plus. So and also some base chlorine etc., which can be exchanged by hydroxide ions. So this is it can be used for the basic concept is here is for demineralization of water. The complete demineralization, what are the minerals present in the water can be removed by ion exchange chromatography. So here sodium, calcium, magnesium can be removed by H plus ions, and chlorine, nitrogen oxide, sulfur oxide are removed by hydroxide ions. So this is the application use. And for the sulfonic acid resins employed as a cation, here you should be knowing sulfonic acid is used as a cation exchange, while strong basic resins is employed as an anion exchangers. For example, for cation exchanger, sulfonic acid is used, and for anion exchanger, some base can be used for the separation. And some of the strong acids already I told: hydrochloric acid, nitric acid, sulfuric acid, hydrochloric acid, and strong bases: sodium hydroxide, potassium hydroxide, calcium hydroxide, and barium oxide, etc. These are used for strong acid versus strong base, and it is generally with versus the strong acid versus the weak strong base, weak acid with the weak acid versus the weak base. So the ion exchanger mainly depends on the ions. So this is the concept in what? Ion exchange chromatography. You should be knowing in this unit, you should be knowing the principle why you are going to use the ion exchange chromatography. It is mainly used for the separation on the basis of charges present in the ions. So the ions get exchanged with the stationary phase. This is the basic concept in ion exchange chromatography, and there are the ion taking cation exchange regional and anion exchange regions. These are the two concepts you should be knowing, and further the mechanism how it works by diffusion of the ion through matrix of the stationary phase, and further it is separated. So and their instrumentation and some of the factors which are affecting equilibrium constant and applications are 4 points are there, separation of similar ions from the similar ions and removal of interfacing radicals and softening of hard water and demineralization of water. This is the concept in this ion exchange chromatography. Now, doubts ಇದೆಯಾ?